incorporated in 2021. Our company started off as a biotech company. I'm a chemist, biochemist. I went to grad school for biochemistry at San Diego State in California. We started off doing drug delivery technology for pharmaceutical companies. We have a unique technology that combines transferins with different proteins and compounds that help improve the oral bioavailability of these types of compounds. Sorry, I'm a little out of breath from walking in here. We developed these technologies for a lot of biotech companies back in the early 2000s. Around 2008, we transitioned from doing pharmaceutical biochemistry, biotech stuff to focusing on dietary supplements. A lot of it was just because the market changed. Went toward less pharma. There was a financial crash and all that, and just dietary supplements became more important to us. We have over 50 patents worldwide, all around biochemistry, combining fats into lipids like liposomes, micelles, cubosomes, which I'll get in more detail later. And a lot of our patents are regarding transferins and lactoferrin bound to proteins and compounds, which we call our DP technology, which is direct precision technology. Lactoferrin bound to different compounds and peptides, won't get too much into that. Lactoferrin binds iron in the gut and opens up a pathway in your gut. It binds to a liporeceptor protein to deliver the iron systemically, and then recycles back out, trying to look for more iron. We tag on or vector different proteins like insulin. Nowadays, we do it with glutathione, growth hormones, BPC-157, and it mimics injection, over 61% oral bioavailability. So that's a little bit about VIRUN. We're here stuck with this name, VIRUN. It stands for virus immune, because we were working in pharma, and here we are doing supplements. The weird thing is no one asked me about that. It's why does your company call it sound like virus? But that's a story. It's why. Sometimes we get people who are Hindus think that we're named after the goddess of water, which is VIRUN, and she rides a crocodile. But that's not it. But I try to just tell people it is because it sounds more interesting than virus. But the acronym virus immune, there's a point to it because we deliver things similar to a virus. It basically invades your immune system naturally by using, say, lactoferrin, liposomes, things like that are natural. It just helps engage your immune system so that things can absorb and increase bioavailability. With that said, let's talk about absorption and try to get into the nitty-gritty of what we do. So fats. Fats don't absorb very well. Your gut is composed of polar lipids, your gut microbiome, your gut mucosa, and your gut can't absorb things that are fat-soluble very well. So it goes through a process called micellization, which is basically taking fats from food, DHA, CoQ10, from meats and different compounds that are naive. They don't absorb very well. And micellization is the process of making your body accept these things a little bit better. Your body does it naturally, so as long as there's phospholipids and things in your gut, that it can help micelize and create lipids, which form a micelle, and then your gut absorbs it. So for example, you ingest food, it converts that food into a liposome. The liposome then breaks down into a micelle, which is much smaller, and absorbs across your brush border membrane. The absorption is a biological effect. It's your natural pharmacokinetic to absorb fats where you wouldn't absorb fats otherwise. A good example is you get a steroid or a drug from a doctor and they tell you to take it with food. That is due to micellization so that your body can help absorb these things. Steroids are I'm not saying they're good for you by any means, but as a scientist, these are just the explanation of the biology. But yeah, your body needs a micelle. The steroid, if you have egg, in particular egg yolk, that's where you have phospholipids inside the egg yolk, and that helps micelize these things so they absorb better. When you eat, say, a piece of salmon, The DHA omega-3 is actually naturally bound to a phospholipid called phosphatidylcholine in the salmon itself. And other examples are, again, egg, other example, CoQ10 in meat or something like that. They're all naturally bound to these lipids. And when you ingest them, your body receives those bound to a phospholipid and recognizes it as a liposomal form. As it goes into the gut, meets with bile and water and all these different things, it forms the liposome. And the liposome comes down, actually breaks down, kind of peels like an onion. And it takes these ingredients, say DHA from the salmon, and converts it into a liposomal form and then a micelle form. The liposome peels like an onion, slowly releases the DHA, which then self-assembles into a micelle and reaches the intestines. And then you have these lipids, like I mentioned before, that are polar. And these lipids are about 10 to 20 nanometers apart from each other, and they actually look like this. You know, I don't have too many cartoon images of that because, I don't know, I always argue with my professor about cartoon images explaining science. But you have a brush border membrane, and then 10, 20 nanometers here. The DHA micelle, forms a micelle, and the micelle is about 10, 20 nanometers here, and it just absorbs through that, becomes systemic, and then the DHA gets released in blood plasma. And that kind of is a lot of this stuff explained in a more layman's terms. I always say the best liposomal manufacturers, because everybody's hearing liposomes recently. We were working with liposomes back in late 90s, early 2000s. I myself am 85 years old, but I take my own supplements and I just maintain a youthful look. But it's ridiculous. Some stuff I hear on Instagram just makes me want to throw up. But yeah, the way other people explain liposomes, they make it sound like it's a lot of science and a lot of fluffy stuff and biotech this. And the way they explain liposomes, it's almost like nanotechnology, which it's not. Liposomes are larger particle size, typically around 300 nanometer particle size. Nanotechnology, if you explain nanotechnology, you're more of a micelle. A micelle, is defined as, or nanotechnology with a micelle is defined as less than 100 nanometers. And that's small. And that's great if you want to create a beverage and you want to put DHA omega-3 or vitamin D in there and maintain a clear look, then you would want a micelle and you want nanotechnology to do that. Other examples of nanotechnology, pickle jar juice. They create nanotechnology using polysorbate 80. We use our Esolv, which is a natural vitamin E. But liposomes are larger in particle size. Some examples of liposomes are as simple as mayonnaise, rice milk, and this is what I was getting at before. The best liposomal manufacturers that I know of are French sous chefs. And think of hollandaise sauce. They use the phosphatidylcholine, the phospholipid from an egg yolk. Their manufacturing process to make a liposome is a whisk. And they take the egg yolk and there's some fat, there's some butter as an emulsifier, then you have the water or whatever it is that you make. I don't even know how to make hollandaise sauce, but something that's on the polar side. And then they mix that in, whisk it. That's your emulsion process or homogenization. And then you have your end liposome, which is hollandaise sauce. Very simple stuff. I believe this is why the EFSA would not make liposomes as a novel food, because it's not a novel food, it actually is food. If they made it novel food, then we wouldn't be able to eat food. So that explains it in layman's terms. I think that's important because it's not good when people explain things in a very technical manner. Maybe you're hiding something, I don't know. But we formulate a lot of products, and I'll get into that. I love that product, the red velvet one. I go to a company in Hawaii. They grow all our algae. You might know them, Cyanotech. They're on the Big Island in Kona. And I've been working with them, gosh, for 15 years. And Zewski is actually the founder of that company back in 1983. And you fly in. We grow our astaxanthin there, or spirulina, in particular astaxanthin, which is from an organism that it needs to be grown. And you fly into the airport, and you land, and then you come out, and you just drive down the right side. You have Mauna Kea, huge mountain, like over 10,000 feet elevation. There's snow on top. You drive down, you turn to the right into their biotech zone for ocean research. You pull in, and it's the crazy facility. It's considered a farm. You have like just dozens of ponds, and they're growing spirulina, astaxanthin, all this stuff. Very sustainable. They use the mountains of Mauna Kea, the snow melts, the water comes down, it feeds their ponds where they grow the astaxanthin. And that's how salmon have their pink color. And flamingos, because flamingos eat krill, the krill eat the algae that the astaxanthin exists in. We actually feed farm-raised like salmon astaxanthin so that they have that pink hue. So you go in there and you see all this stuff, but yeah, that's cyanotech. That product, we also add like mushrooms to it. There's like a 5 mushroom blend that we grow in Oregon with vitamin K2, MK7. So these are like fats. Things are hard to work with. We have a patent called Creamy Edible Emulsions that we use, which uses almonds and nut butters as a natural emulsifier. We don't use like polysorbates or anything like that. We believe in using natural lactoferrin or using nut butter as your emulsifier to combine oils and fats. Phosphatidylcholine, which is the phospholipid you use to form liposomes, it's extracted from almonds. We use that. We also use a phosphatidylcholine derived from sunflower seed. It's not sunflower seed oil. It's just in the meat of the sunflower seed itself. And that's how we produce a liposome. And we have probably about 50 companies we work with worldwide. We do something called private label. And this is kind of new for us, like representing our own brand. We have a brand, O3 Omega, which we've developed for years, and we want to promote that. That's why we're here today. It's a really unique product. It's DHA omega-3 from Schizochytrium. We grow it, and we process it in Saskatoon, Canada, under a company called Algorithm. Process it. It goes through, they grow it, vats, organism grows, DHA omega-3 is concentrated, and then we take that DHA omega-3, go through a CO2 extraction process, and that kind of just purifies it. CO2 is like an amazing solvent because it's not toluene, it's not benzene, it's not acetone. It's not a liquid, it's not a solid, it's just a gas. So it evaporates out. It's completely natural. So it's a greatest solvent. It's what's used to make my favorite thing, marijuana, THC, CBD, CO2 extraction. So it goes through that process, and then you get the DHA. We process the DHA into the O3 Omega product. We combine it with MCT oil, not sunflower or seed oil. And MCT is a saturated fat, which is great because it helps with ketosis and all that. So people who want to add like our product to coffee, mix in, dissolves, it's vegan, creates a creamy effect using the nut butter instead of dairy. And then DHA omega-3 balances that out because it's a polyunsaturated fat. So you have the saturated fat MCT. A lot of people are using MCT in coffee, need to balance it out. Too many people have too much omega-6s and omega-9s in their diet, not enough omega-3. MCT is a good substitute because it's kind of this weird in-between thing. MCT has some polarity to it too, which is great for like emulsions and for what we do. We do, like I said, manufacture like all these companies. We do multivitamins, liposomal magnesium. It's funny, we were talking about the magnesium threonate before. The company we buy from in the U.S., AIDP, they have the exclusive rights for that magnesium threonate for whoever was here for that call, Magtine. And we process, I don't know, maybe 10 products with Magtine in it. There's lycopene, lutein, vitamin D3, K2, MK7. There's so many like fat ingredients. And one point I want to make before I go in the Q&A thing is the omega-3 DHA, a lot of the omega-3 that you consume today, fish oil, EPA DHA, they're in a soft gel format and very convenient. You can get, up to 1,000 milligrams EPA DHA, which they play games with that because they'll say like 1,000 milligrams of omega-3. And then they don't list the EPA DHA, they list it, but it's kind of it's confusing to the consumer because you have 1,000 milligrams of omega-3, but really you have maybe 400 milligrams of EPA DHA of that 1,000 milligrams. So look for that. But the soft gels, take one, bite into it, and you will see that the oil is completely rancid. If you've heard of fishy burps, when you swallow these soft gels, you get these fishy burps. And there's a lot of research out there talking about EPA DHA when it is rancid and the cause and effect of that, producing aldehydes and things that cause cancer. Fish oil manufacturers and soft gel manufacturers will show you lists of their tests for organoleptics, which is peroxide and nitidine. Really, they don't have any due diligence to test anything outside of that. There's byproduct, and I know that just from my chemistry work. Byproduct produced, which is aldehydes. You don't have tests for that. And you'll actually see these peroxide levels like drop over time, and that's because they're going from peroxide or anisidine, and these toxic organoleptics are forming byproducts, which are actually more harmful than the organoleptics that they test for safety in the first place. So they're just being replaced by carcinogenic aldehydes and compounds that are not good for you. So obviously our stuff is like kind of like a blank canvas, and you get what you buy. The product is free of any kind of rancidity. I always wonder, is like, you go to a restaurant, order some salmon or something, farm raised, of course. I'm kidding. Wild source salmon, and you eat the salmon. If it tastes rancid, what do? You just like, I mean, I've had salmon that's like so putrid that it tastes like turpentine, like beyond fishiness. It's like a whole nother level. I don't want to explain it. But what do? You send it back. It was like, I can't eat this. Like, I will eat it, and then it'll just come back out on my plate. So what's the point? But for some reason, people take soft gels, and they hide it in these capsulated gelatin capsules, and you swallow it, but that's completely acceptable. But not when you go out and have like a piece of fish or something. Anyway, really I'm here today just to kind of deliver some of this stuff in this kind of manner so you understand, educate, and I will open this up to any questions anybody has. And I can't see because there's these bright lights. It's like literally.
I'll help you out of here.
All right.
So I have a question around rancidity. And what do you think about adding astaxanthin into these omega-3 products to avoid it or reduce rancidity?
Yeah, it's just hard to comment on that because you can add it, and then what they do is all the manufacturers, they take the oils and they add that to it, but then it's all frozen, nitrogen blanketed, which nitrogen's used to remove oxygen in the headspace. Liquid nitrogen used to remove dissolved oxygen within the oil itself. So you add it in there, it's going to give you a false sense of stability because it's all frozen. So what really matters is like what happens with that soft gel when it's on a retail shelf at, I'm in Europe, so Holland and Barrett or Boots. We have a facility in Ireland. Our business in Europe is growing like crazy. I love it here because I can see better. It's growing. I know it's supposed to be that way. I'm not complaining. But yeah, you take those soft gels, like no one's like testing this stuff like 5 months into that. How long does it take for that product to get on the shelf? Like, I don't know, maybe it goes through manufacturing, goes to a fulfillment center, they ship it out, trucks, all this stuff. You're looking at 6 months before it's on the shelf. And might have been great early on, but then, so you'd have to take that. I'm not familiar with the stability agent you're mentioning, but you'd have to put that in there, test in the soft gel, test it like in emulsions that we make or whatever, and really just see what happens. That's what I always tell everybody. They come to me and they're like, why don't you try our free tocopherol? It's an antioxidant. It's natural. It's going to work great. And it's like, no, it's not. We've done it. Been there. The best thing we've learned for stability of like fish oils and things like that is just process. Getting the oil, it needs to be perfect from the get-go. So you get it in. It's really clean. No fishiness, no rancidity. It's been processed, not too processed. A lot of the high concentrates, they've been esterified. What they do is they take EPA DHA, which is a natural triglyceride, and then they bind it to ethyl esters, and they process just the shit out of it. And then they remove the ethyl esters, go through deodorization, and yeah, it tastes great after deodorization, which is uses steam. It binds to these bad things, that bad flavor, and evaporates it out. And then you get this stuff, and you taste it, and it tastes fine. but it's been processed so much, because omega-3 has, the way they call it omega-3, it's got double bonds in 3 different places in between carbons throughout the triglyceride. And they've been processed and twisted and turned so much, and cis, trans, all that, that it's weakened it, so that over time, it oxidizes. And when something oxidizes, it's like a snowball effect. It just tumbles. The snowball gets bigger and bigger and bigger, and it just goes off, as we call it. So you need to use the natural TG, natural triglyceride. It's got to be a lower, the concentrates are great in the beginning, but soft gel manufacturers are using the concentrates because you get a better claim on your label. They're using these highly processed oils. They're natural, but they were produced with ethyl esters in the beginning and then removed. Almost better leaving the ethyl ester on, but then that could be like, even a drug claim, like a lot of the, whatchamacallit, the cholesterol lowering stuff, statins, couldn't think of it. They're all esterified EPA/DHA is really what they are. And so that's why a lot of companies have to remove that to have that claim. So yeah, short and the answer, which that was not short before, is just got to run whatever finished product you're making, you have to run it and see what happens.